to pay for antiretroviral therapy. That was launched under President Bush. Yep.
We've already discussed that rates are highest in wealthier urban areas, so that can further hinder development.
That's right. So if we think that lots of innovation or technological change or manufacturing, et cetera, are going to go on in urban areas and they're hardest hit, maybe that's particularly costly. Okay, so you guys have raised a bunch of these issues. I had put a couple in. You guys sort of got all of them right away. The labor productivity issue. There's a labor turnover issue. So even beyond productivity, when people are in a job over time, their experience in that job is often associated with higher productivity. If you're working in a particular company or organization, you learn how to do things efficiently in that system. So even if you were to replace one skilled worker with another skilled worker, there's a loss of productivity there. Again, speaking in these very crass economic terms, we're talking about people dying, which is much more important. But this does have economic consequences. There's the human capital issue in terms of the education of age orphans in the next generation, and then this issue of investment and savings rates changing. So really a lot of different economic factors at play here, to the extent that as was mentioned, high-skilled, high-education folks in urban areas are hit particularly hard, then all these effects are potentially magnified in terms of overall economic production. Okay, so you guys did a really good job bringing out these issues. What I want to do next is, instead of thinking of the theoretical or conceptual issues, turn to estimation, empirical estimation, and turn to estimation of impacts in a setting like, say, the spread of HIV, where we may not have an experimental design or randomized experiment. Now, you could imagine the existence of randomized experiments around, say, the introduction of antiretroviral therapies, but that's not what I'm going to focus on here. I'm going to focus on how we try to understand the impact, in this case on labor productivity, of people falling ill with AIDS in a non-randomized setting. What can we say that's convincing, and what assumptions do we need to say something about the effect of falling ill with AIDS on labor productivity? And what we're going to focus on is what's called the use of panel data, or what is often in other fields called longitudinal data, but it's really the same thing. And what this is data for which we have observations on multiple individuals, say, or multiple communities, over multiple time points, more than one time point. And the question is, what can we say about causal impacts with multiple time points that we couldn't say when we only had data at one time point? What we would call, the opposite of panel data would be cross-sectional data. So cross-sectional data is data for many individuals or many communities at one time point. But now if we have 2 or 3 or 4 time points, can we actually say things with more confidence? That's the question we're going to ask, and we're going to try to be as precise as we can about the assumptions you need to make causal claims. Okay, so this is the sort of estimation equation we had on the board last week or 2 weeks ago. We went through the sort of y equals a plus bt plus bx plus e. We talked about what we get in terms of a quantity when we compare the treated and the untreated. And, the basic point here is we get some combination of the true effect of treatment plus omitted variable bias. And this is the reason why in the deworming study, say, or in lots of the other studies we'll go through this term, we turn to a randomized design, because with a randomized design, there's no reason why the unobserved characteristics of the treated and the untreated should be different. So this term disappears, right? That's what we've been talking about. But now let's imagine a case where we don't have a randomized experiment. But what we do have is we have 2 time periods. We have a pre-program period, which we're going to call the baseline period, and we have a post-program period, which we're going to call the follow-up period, or the follow-up surveys, follow-up data. Those are the 2 time periods. Pre-program, there's no treatment. So t equals 0 for everybody here, for simplicity, the pre-program period. Post-program, some people are treated, not everybody. So there's some variation into who gets treated, and that is not randomized variation. The types of people who get treated could be different than the types of people who don't get treated. And that's the problem, and that's why we only have a cross-section. Let's say if we only had t equals 1 data, not t equals 0, we're not going to be that confident comparing the treated and the untreated, because we know they differ in all these systematic ways, potentially. Okay, so for concreteness here, we're going to talk about a very specific event. So t could be an event, it could be a treatment, it's any sort of intervention or event. And the event here is going to be individuals falling ill with AIDS, and the outcome is going to be their labor productivity. So we want to get a sense of how the labor productivity of individuals is affected when they become ill. And this gets at the point that was raised before, that what is the labor productivity impact of AIDS-related morbidity? This is a big deal in Southern Africa, say, where 15 or 20% of adults are HIV positive. It's something that we need to understand. And this is exactly the question that's asked in the Fox et al. Article. So the nice thing about that article is it's very short and tight, and they present the results in a very kind of simple way. But they don't really talk through the methodology that much in that article if you've read it already. They kind of assume you know what a difference in difference design is for the most part, so it's useful to actually walk through what they're doing in a little bit more detail. So they look at the productivity of workers on Kenyan tea plantations. How many kilos of tea leaves are you able to pick in a day? That's Y here. Okay, so in t equals 1, we have the exact same equation we had before. The only thing that's different is now we have these nice time subscripts. So this is period 1, the post period. This is exactly the same equation as before. If we only had the cross section in t equals 1, we would say the difference between the quote treated t equals 1, those who fell ill with AIDS, and those who didn't, is that difference. The true effect and omitted variable bias. Now, what are some omitted variables that may differ between those who fell ill with AIDS and those who didn't? Just what are some of the, based on our discussion earlier today or other things, how many of these individuals differ in the cross section? Yeah. So there's a gender difference. We may have data, we may be able to control for that, but maybe we don't have good demographics. Yeah. The things that we show, wealth and education differs. And again, if we don't have great controls for all of that, maybe if we're comparing the treated and the untreated, we're comparing, wealthier, more educated women on average to less wealthy, less educated men. If we don't have good socioeconomic and demographic controls, we want to control for those things. What are some other differences? Yeah, there you go. That's right. So their sexual behavior, how many partners they have, what kinds of risks they took, for instance. So to the extent that people that engage in more risky sex are more likely to get infected, that may be a difference between these 2 groups. And if we think that, and again, this is extrapolation, but if we think that people who take risks in one part of their life are more likely to take risks in another part of their life, or have different sort of work practices, etc., maybe that sexual behavior correlates with productivity. Maybe. I don't know exactly what the channel is, but who knows? Maybe there's some correlation. Yeah. Age could be a factor. We showed very strong age effects. Again, if we didn't have good enough controls for those basic demographics, we'd be sort of confusing those effects. Yeah. Yeah, so family size or the nature of your family situation could both affect maybe how you view your job, but also affect how many partners you have, right? I mean, that would be a very clear one. So the nature of the kinds of family relationships or partners, the type of partner you have, etc. Okay, so you guys have pointed out a lot of things, but the point about sexual behavior difference points to this issue that maybe there are certain types of individuals who they're almost, we saw from the day before, certain types of individuals are more likely to be infected, and if any of those variables correlate with labor productivity, we could be in trouble. We could have omitted variables in this regression. So now let's turn to the baseline period. So let's do the same thing we just did, but now using the baseline data. Let's compare the productivity of the t equals 1 and the t equals 0 at baseline. But what are we doing here? We have this data after the collection of the end-line data. So we actually know in the end-line data who's going to become ill with AIDS. So we can go back to the baseline data and define t sub I1 equals 1 and t sub I0 equals 1. Sorry, t sub I1 equals 0. You see what I'm saying? We know who's going to become infected. We know for whom t will equal 1. So we go back to the baseline data and compare the people who are going to get infected to the people who aren't. That's what this difference is. Is that clear? It's a little bit funny. At the time that data was collected, everybody was healthy. No one had fallen ill with AIDS yet. So at the time we collected the baseline data, we couldn't have known who was going to become ill. But now that we're doing the analysis after the collection of the end-line data, we can. So we can look at this difference. And what is this difference? It looks very similar to what we had before, except for one thing. No one was infected at baseline. There's no treatment effect at baseline. No one was ill with AIDS at baseline. So what we have is we have omitted variable bias, or selection bias. If everybody's healthy and nobody's ill, the comparison of the productivity levels of these two groups at baseline just reflects their sort of baseline omitted variables, or selection. It can't reflect falling ill with AIDS because no one has fallen ill with AIDS yet in this data. Why is this potentially useful? How should we think of this data? Okay, so we'll talk about the conditions we need, but that's the basic intuition. Think of the baseline data as providing a sort of internal control. So for some people, I view you when you were healthy and when you were sick. And for other people, I view you when you were healthy and when you were healthy. We kind of compare those two differences to get at the effect of being sick. Right? So let's do that more formally, but think of this as a sort of internal control. We're observing, for the people who are t sub I1 equal to 1, we're observing them when they're healthy, and we're observing them when they're sick. That is very useful for us. Okay, so let's do the difference and difference exactly as suggested. Take the difference between equations 2 and 3 that I just put up. What does this equal? Well, you just go through the algebra here, and this is what you get. You get the true effect, b, plus this second term. So what is this difference? It's the omitted variable bias in period 1, the end line, minus the omitted variable bias in period 0. In other words, it's the differences in productivity between these two groups due to omitted variables or due to selection in each of the two survey points or times. Does that equal 0? When will it and when won't it equal 0? It's not the same thing, right? There is this subtle difference. Saying, well, maybe someone can explain. Yeah. Okay. So if those unobservables, at that x, so right now we've written the x with a time subscript. It can either have the time subscript of 0 or 1. But if we think this unobservable is fixed over time, it's some dimension of your personality, it's some aspect of some fundamental personal characteristic that's unchanging over time, then that should difference out. You had your hand up as well. Basically the same point? Okay. When won't it hold? Or we just said when it holds. What are some of the characteristics or some of the omitted variables for which we think that difference is 0, and what are some for which we think that difference is definitely not 0? Yeah.
Well, kind of like, this is physical labor, so maybe inherent endurance. I just always been healthy. I got more food as a child. I can work 6 hours a day. My neighbor told me, you can only manage 5. It's just a smaller guy giving you enough prenatal vitamins or something like that.
So something that's just driven by these long ago investments, or sometimes people when they look at labor productivity in low-income countries focus on height. It turned out folks who have better nutrition in early childhood tend to be taller and stronger and sort of have better ability to do manual labor. So something like one's height would be pretty fixed. So if we think height is the unobservable, that'll difference out. What is something that might not difference out? Yeah, Lauren. That's right. So age is something that changes over time. And if there were big differences in the age of the t equals 1 and the t equals 0 groups, this may not difference out. Okay, what are some other characteristics? Speak up a little bit.
Sexual behavior, the same age as you grow up in sexual behavior, right? Very big, so that would be different.
So maybe sexual behavior changes over time, and the nature of the differences between these groups could evolve in various ways. Yeah. Mm-hmm. So maybe access to technology would differ over time, and that could affect these differences. I mean, that's a pretty interesting point. So if we think, for instance, at baseline, everybody was picking by hand. And in the end line, they had automated pickers. And you just had to operate an iPad to pick all the tea leaves. It was like an automated factory situation. The kinds of characteristics that made you a particularly unobservably good picker in period 0 might be very different than the unobservable characteristics that make you a good picker in period 1. So that's an interesting point. Any other thoughts on when this is going to be plausible or implausible? Okay, we'll talk more about it coming up. But the big question here is when does this equal 0? And going back to our earlier discussion, we talked about when is omitted variable bias not a problem. We said, well, we can collect data on the x's. Maybe there is no omitted variable. Point 3 here was our earlier solution. We're going to randomize. That isn't feasible in the data we have here. So this is our fourth solution for omitted variable bias. If we have panel data and the extent or the degree or the nature of omitted variable bias is constant over time, then it's going to difference out in difference and differences design. So if it's based on your height and that sort of has a constant effect on your productivity over time, it differences out. If it's a function of some basic personality characteristic or cognitive ability or something else we think is very stable over time, maybe it'll difference out. But if there's other things changing over time, like the nature of technology, which affects who's a better picker, or something else that's changing over time, we talked about age and sexual behavior, then maybe this difference and difference won't give us reliable results. Did you? Yeah, so you're saying the overall productivity level can vary before or after. The key thing is going to be the difference between group 1 and group t equals 1 and group t equals 0. I realize that what I'm saying with t's is very confusing. This is t and this is t. I'm going to use a different subscript in the future. When I say t in a soft voice, I mean this one. No, that's not it. This is time, right? So this is little t, but this is like treatment. So this is confusing. I'll change the notation. But what I mean is there can be changes in overall productivity over time. That's fine here. Those get differenced out. But the nature of the differences across t equals 0 and t equals 1, those two groups, that can't change over time. Okay. So let's, this is a little bit more discussion. We've pretty much gone through here. And I want to focus on this case of the Fox et al., which is to say, well, Fox et al. Make the point that lots of things did stay the same during their study periods. If we think that on this tea plantation that they study, the work rules, the technology, the labor conditions, etc., were pretty much the same over time, is that enough to assure us that the difference approach they take is reasonable? I think that's the question we should ask ourselves in their setting. When you read or reread their article, keep in mind, are there other things that may be evolving over time that that would potentially violate the difference. So let's focus in on the Fox et al. And get into their study now in the last 2 or 3 minutes, and then we'll finish it next time and go on to modeling risky sexual behavior. So this Fox et al. Study is really interesting. They collected a really amazing data set. It's administrative data from a large tea plantation in Kenya over 5 years. So the tea plantation keeps records of how much tea pluckers pick. Why do they do that? Well, they pay the tea pluckers based on how much they pick. So everybody has an interest in recording that accurately. The workers do, the management does, because that determines their how much they pay the workers. The other interesting thing about this setting is they have extremely detailed health records on all their workers. Why is that? They have a health clinic on the plantation, on site, and workers get access to that clinic. So the workers in these plantations basically live right near the plantation to make it convenient to get to work. And there are a number of amenities. It's like a company town, we would say, in U.S. historical terms, where there'd be a big factory and everything the workers needed was sort of within a mile of the factory. That's what a lot of these tea plantations are like. So there's a clinic on site, workers get access to that clinic, and their health status is recorded by the company. So the company knows their productivity, the company knows their health status, and in particular the company was regularly testing workers for their HIV status once they became ill. So once people reported being ill, they would be tested. So we actually have that data in the data set. So this is a really amazing data set that you wouldn't be able to sort of collect on your own for a couple of reasons. A, we talked about this a little bit with deworming. In general, it's hard to measure agricultural productivity on someone's own farm, say. And that's what the bulk of the workforce does in rural sub-Saharan Africa. These guys don't have that problem because the productivity is literally the kilos of tea. So we solved that problem. B, it's hard to get reliable records on health behavior. That's been solved here too because the clinic that's on the plantation has the data. And what they do is they compare the productivity of 270 workers over time, and they know when the workers become ill. And they ask the question, once you become ill, how much does your productivity fall? So due to HIV-AIDS-related morbidity, how much does your productivity fall? And this is your productivity before you have to leave work because you're so sick you can't work anymore. This is the period before there's antiretrovirals. So a lot of these guys that are getting very sick are then going to die, unfortunately, sadly, soon after they leave work, usually. So there's really no treatment for HIV at that point. But the question they're asking is along the way, how much does your morbidity affect your productivity? Where the event here, which takes on a value of 1, is people falling ill with AIDS. So let me pause there, and on Thursday we're going to continue just going through their results in a difference in difference framework.